This is 20 Minutes of Impact from the United States Energy Association Power Sector Podcast. I'm Herman K. Trabish. I've covered the power sector since 2000, and I currently report for Utility Dive. In this episode of the podcast, we're going to talk with Ann Collier, Senior Manager for Emerging Technologies with the Smart Electric Power Alliance, or SEPA, which brings utilities, clean energy stakeholders, and policymakers together to accelerate smart energy policy. Ann's going to describe the new Delta database developed by SEPA with the North Carolina Clean Energy Technology Center to catalog the many quickly emerging rate designs or tariffs for the new large loads like AI data centers that everybody's talking about. Ann began her career in research and environmental advocacy in 2007. After nearly a decade in the private sector as an environmental economics analyst and project consultant, she joined SEPA in December 2021 and became the Senior Manager for Emerging Technologies in 2023. So, Ann, we're talking about a large load tariffs. We're talking about a large load tariff, excuse me. What is that? Why is there a need to catalog them? And how is this new database intended to be used?
Thanks for having me on, Herman. Hey, everyone out there, Ann Collier. I do work at SEPA. It's true, the Smart Electric Power Alliance. So thrilled to be able to share with you about Delta, the database of emerging large load tariffs, which we've developed in close partnership with our friends at the North Carolina Clean Energy Technology Center. Before I dig into, the fantastic and highly nerdy world of tariffs and what is a large load customer, just wanted to share a little bit more about SEPA. We're a nonprofit convener, we're an educator. We work with about 1,000 member organizations across the power industry. We're all about accelerating progress to an affordable, resilient, and clean energy system. So in my job, I help members find solutions to challenges at the intersection of these objectives. It's not really an easy task to do all of these things at once. So particularly as we're looking to enter this new era of load growth as a country, one of the biggest challenges that our members are coming to, utilities, utility regulators, and a variety of other stakeholders, they really want to know what to make out of data center load growth. The forecasts are really quite variable, and can share a little bit more about that later in this conversation. But, figuring out what they are and how to deal with them is a top priority for a lot of our members. And tariffs are one way that we can deal with this. So just stepping back, a little bit, what is a tariff? These are, in the utility context, a set of rates, service agreements, and special contracts that really specify how a utility is going to provide electricity to a particular type of customer, how they're going to price those services, and what they expect from the customer in return. Whether that's a commitment or an agreement.
Excuse me for interrupting, Ann. I apologize. Hold that thought. I just want to thank you for explaining that. Tariff is sort of a rate design, but it's much more. It has a lot of rules and so on about how that rate is applied. But it's something that word happens to have a certain weight these days, and it's really important to know that how relevant this database really is. But go on, I interrupted you. I apologize.
I took, just a moment to level set the kind of tariffs we're talking about. Are very specific, right? And utilities since existence have had a variety of tariff structures out there. You and I have tariffs that, inform how we pay for our electricity at our residences, right? So large load tariffs are this new kind of specialized commercial and industrial rate structure for this emerging class of very, very big customers, thinking 50 megawatts, 100 megawatts, 200 megawatt data centers are often the focus of these very large load mechanisms. Utilities have long made upfront investments in serving very large customers, whether it was a mine or a casino. We met at RE Plus last week, right? Lines, substations, or even, planning ahead to procure new generation to serve an increase in load before customers pay back for that investment on their bill, right? And so tariffs are the way utilities structure how we recover how utilities recover upfront investments made on behalf of customers. And if you're a rate regulated utility, this needs state regulatory approval. So the contemporary variants that we're seeing right now are really designed to manage some of the emerging risks that people see in ramping up data centers in particular to meet the AI moment. So designing in beefier financial protections that folks are seeing necessary for just managing utility and consumer risks of serving these unique large loads, sort of at this time where there's incredible momentum to develop new large loads. Data centers are driving the conversation, but I think there's also the hope for large electrification and manufacturing. But there's also a lot of hype and kind of uncertainty about how fast and when this momentum will really materialize into power demand. So to your question, why we need to catalog these, it's a pretty nerdy endeavor, right? We're doing it now because the space is moving, quite frankly, incredibly fast. We have almost 50 tariffs in Delta right now, 49 to be precise. I was looking at the numbers. 4 out of every 5 of the tariffs we have were introduced or approved in just the last 3 years alone. So if it feels like we're moving quickly, it's because we are. Utilities and commissions and their large customers are moving really quickly to respond to accommodate the expected surge in demand. And I think it tells you something about the real gravity of the situation that utilities are in right now. And I love talking about the space, so I'll tell you a little bit about that, Matt, right now. It's called Delta. I had a little bit of AI help, I'll confess, to arrange our topic into a nifty acronym, because we know the power sector loves one of those. Database of Emerging Large Load Tariffs. It's free. It's free, it's public, it's focused pretty closely on these contemporary large load tariffs. It's available at sepapower.org. Tariffs are a live topic. Everything is in process. So we'll be updating this quarterly. And we in the North team.
Can I
go ahead.
ask you a question, Ann?
Yep.
It seems to me, and correct me if I'm wrong, but this database is really going to be important because large loads are emerging sort of everywhere, and we'll get to exactly where and what they look like in a minute. But everybody's heard about all this talk, and utilities and their regulators are scrambling to create these tariffs that balance the need to bring on these large loads with the cost of bringing them on. So it seems to me that you're cataloging them. The database will be able to be a resource for all these commissions and all these places that are seeing new large loads and want to figure out, well, how can we best establish rates for them? Is that right? Am I getting that right?
That's totally right. Yeah, I probably took too long with the lead up, but right. Like if you have a well-staffed team or a great consultant or some software, it's very easy to keep tabs on what's happening in these dockets or other dialogues that are happening. We saw a real need to kind of set the table for everyone, just how fast this topic is moving. We know it's top of mind for so many people in the power sector. So we take it upon ourselves to go through the dockets, sort of filter through what's relevant and interesting and emerging, synthesize and categorize these tariffs based on the original source documentation in PUC dockets on utility websites, really responding to industry interest and novel features. Are we seeing new mechanisms to manage a particular kind of risk? Well, we go through and kind of flag which of the tariffs in the catalog are testing out those kinds of tools. So the aim is to make it very easy for regulators, utilities, consumer advocates, even data centers or investment firms to sort of compare what's out there, explore what might work in their own context. And the early feedback has just been tremendous. We got a lot of thank you notes, right? Like, this is exactly what we needed. And we knew we'd really met the industry moment. My friend and colleague posted about it on his LinkedIn feed. We knew we had hit the market need. It got like 800 likes and 50 reshares within a week. And I didn't know it was possible to go organically viral on a place like LinkedIn anymore, but just a testament to the uptake and the interest, really for a map and a database and a really easy tool to get oriented to the topic.
Let's get a little bit more granular now. And first of all, I want to mention that the North Carolina Clean Energy Technology Center worked with you guys on this, and they are really good at handling all the things that are going on at commissions and putting them in a usable and accessible form. But let's start with this question. And how many, we're recording this at the end of September. Um, how many new large load tariffs have been developed? And what do they cover? What kinds of loads, large loads do they cover? Where on the power system are you seeing these large loads come in? And I guess I should say, when we're talking about numbers, when are you going to have to do an update? Because I'm sure that since you've calculated 49 large load tariffs, there have been more.
Totally. And yeah, just to share mutual appreciation for the folks at the Clean Tech Center. They're tremendous partners and really enjoy working with them on this. So right, as of September, Delta includes 49 tariffs, to be precise, across, I think it's 44 electric utilities and 30 states. Of those tariffs, most are approved. There are a good chunk, maybe 20 or so, that are pending regulatory dialogue and approval. So yeah, this dialogue is happening in real time, and we, as a service in the database download, you have links to the commission docket, a final approval order when it's ready, and then the final utility website. So we are planning an update every quarter. Next one will come out in November 2025. So stay tuned.
So, and they cover large, when we talk about large loads, everyone immediately jumps to AI data centers. I think you mentioned a little bit about this earlier. There's other large loads. I mean, a lot of our federal policy, such as it is attempting to reshore manufacturing. And that means manufacturing facilities that draw a lot of power. That's what we haven't actually mentioned, that the kind of wonky term load actually is demand for electricity. So,
Right.
And then you have electric vehicle charging centers, and they're going to add very large loads, especially places out on the highways where big semi trucks that are electric are going to recharge, right? So I guess what you're saying by those numbers that you mentioned is that these tariffs are being developed everywhere, and for all kinds of loads. Is that, am I summarizing it accurately? I'm probably being a little bit too summary oriented there, but
It
I got it
is
right?
it's a national conversation for sure. You know, I think when you think about the kind of customer that might benefit from these provisions, or maybe the size of the load may bring risks for utilities and existing consumers. Just by the numbers in our catalog, about half of those tariffs are aimed at loads a megawatt or more, up to 100 megawatts. And that's a tremendous range, right? But I think, you know, we look at that and we think this could be a mid-sized co-location style data center. This could be your conventional industrial energy user. Certainly, I think fair to think expansively about the future of large loads that we would like to have in this country. A year ago, I was looking at clean hydrogen. And if you're going to go with an electrolytic approach, that's certainly got, you know, quite a different power draw than a data center, but large, you know, I think. So I would say that there are a quarter of these tariffs that we're cataloging that are pretty clearly designed for a hyperscale data center, although there's, you know, the only customers who are allowed to take service on these tariffs are 100 megawatts or more. There are a couple of other tariffs that, you know, go softer and broader and maybe less focused on the size of a load, but more on long-term contracting and provisions and that nature. So I would say, in summary, data center driven, but the intent is to be expansive and certainly non-discriminatory. A big, you know, piece of the dialogue is, you know, making sure that all customers, regardless of what they're doing at their business premise or the technology they may have equal access to the grid. So I know that it's a hot topic in places that have proposed data center oriented tariffs. They've seen a lot of dialogue around the applicability terms.
Yeah, it's such a it's such a hot topic. Let's drill down just a little bit deeper now. And um, you talk about risk. You mentioned that a couple times in answering some of my questions. You want to minimize risk, but we haven't really defined what that risk is. What I want to ask you what outcomes these large load tariffs are designed to achieve. And in order to ask that, I think maybe I should ask you to better explain uh, why large load tariffs, specific tariffs for large loads are needed. In other words, there's something that happens that's when large loads are brought on. It has to do with investments that are made to accommodate them. You have to build new wires, you have to build new substations, you have to build a lot of, you may need to build a lot of infrastructure. There are people that are working on flexibility as a solution, but basically that those expenses then lead to a challenge because you're spending a lot of money for one big uh, user electricity on a system that has hundreds, thousands, maybe millions of other users. So what is a tariff supposed to do in order to sort of balance that problem?
Yeah, tariffs are trying to do a lot. There's so many factors to balance and objectives to pursue here. To me, some of the biggest questions right now are about how much of this forecasted load will materialize and when, and how to forge a path for these grid investments, like you're saying, when you don't really have complete confidence that all of this load will actually show up. And then therefore, maybe you build in anticipation, but then nobody's using that infrastructure and it's tough to recoup the costs through rates if nobody's using the infrastructure. And the risk there is that you saddle a stranded asset, the cost of that, and you have to socialize it across all the rest of the consumers. And as many folks are paying close attention to right now, costs are rising for us across the board, no matter what. So the last thing we want to do is, add this new sharp risk. So the perspective that I kind of go back to is that at a national level, the scale of the problem, Lawrence Berkeley National Lab came out with their US data center energy use report late last year. And in 2028, their forecast for data center electricity usage varies, like the variance from max to min is 250 terawatt hours. That's like saying, right? That's like saying as a nation, do we need to provide the amount of annual power equivalent of 64 Hoover dams or 7 Vogtle nuclear plants or not, right? Like it's a big scale of question that we're facing here. So utilities are all solving this in different ways in their own local levels. The issue tends to be concentrated in places that have had the longest duration of data center development, really hot tier 1 data center markets. So those have been our first moving utilities.
If you want to hear the big last exchange of this terrific conversation, support the podcast by subscribing at just $2.99 per month to the Power Sector Podcast's Power More. With your subscription, you'll get both parts of the content delivered directly to you the second they drop.